Linear programming problem. Today we are going to discuss algebraic method and simplex method. Let us take this problem. Maximize z 10x1 plus 9x2 subjected to constraints 3x1 plus 3x2 less than or equal to 21, 4x1 plus 3x2 less than or equal to 24, and x1 and x2 greater than or equal to 0. So this can be written as, so this is an inequality constraint. So we make it to equal constraint, equal, there is equation. So we are adding two variables, that is called slack variables. If 3x1 plus 3x2 is less than 20, say 20, then we have to add something, that is x3. So plus x3 equal to 21. 4x1 plus 3x2 plus x4, that is equal to 24. Normally we have x1, x2, x3, x4 greater than or equal to 0. Here we have four variables called x1, x2, x3 and x4, and we have only two equations. So at a time we can only take two basic variables and another two basic variables are shown to be 0. Right? So here in algebraic method we have some steps. So how many steps required? That is decided by NCM, where N is variables, M equal to equations. So there are four variables x1, x2, x3, x4 and two equations m equal to 2. So 4C2 is nothing but 6. So totally in this problem we have 6 steps. Initially, the easiest way to solve the problem is assuming x1 and x2 0. Right? We have to find out the solution for x3 and x4. So x3 and x4 are called basic variables, the variables that has to be solved. And here non-basic variables means variables fixed to 0. So in the previous, that is the main problem, assume x1 and x2 0, then x3 equal to 21, x4 equal to 24, z equal to 0. So this is called basic feasible solution. Then change everything. At a time we can consider only two variables as basic variables and two variables as remaining two variables as non-basic variables. So currently we are considering x1, x3. So change everything, right? x1, x3, x2, x4. So find out x1 equal to 6, x3 equal to 3, x3 equal to 3, z equal to 60. This is also basic feasible solution. Then go for another combination. Try all 6 combinations, right? x1, x4 called basic variables and x2 and x3 equal to 0. So we find x1 and x4. x1 is nothing but 7, x4 is minus 4. So is violating the rule. So according to our rule, x1, x2, x3, x4 should be a positive integer, greater than or equal to 0. Right? So it is negative value, so it is infeasible. Then go for another combination x2, x3 and equate x1 and x4 0. Then here we are getting another negative value, so it is infeasible. So two solutions are infeasible solutions. So go for next x2 and x4 as basic variable, x1 and x3 as non-basic variables, z equal to 63 is also basic feasible solution. And finally last one, x1, x2 as basic variable, x3, x4 as non-basic variable, the x1 equal to 3, x2 equal to 4, z equal to 66. So we have 4 z values, that is basic feasible solutions. Among 4 values, the last one, z equal to 66, that is the largest one. So our aim is to maximize z. So this is the optimum value. So the answer is x1 equal to 3, x2 equal to 4. The same thing can be solved for minimization problem. So here we see minimize z equal to 7x1 plus 5x2. Substitute the constraints x1 plus x2 greater than or equal to 4, 5x1 plus 2x2 greater than or equal to 10. As usual, x1 and x2 greater than or equal to 0. So it can be written as like this. Now, you see the first constraint x1 plus x2 greater than or equal to 4. So this is the inequality constraint. So we have to convert the inequality constraint into the equal sign. So now let me assume x1 plus x2 equal to 5 or 6, whatever it is, right? More than 4. If it is more than 4, then some value has to be subtracted. Right? So that is called x3. So put minus x3 equal to 4.